Most people look up and see a solid, static block of carved stone, functioning simply as a cultural icon. The reality is more complex. This is a 1,145-ton structure sitting 700 meters above sea level, taking direct hits from Atlantic storms and winds that exceed 200 kilometers per hour. These physical factors pushed the project to the limits of 1920s design, requiring structural solutions that went beyond the standards of traditional stone construction. The project began in 1921, when Brazil commissioned a monument for its independence centenary. After an initial design was mocked as Christ with a ball, engineer Heitor da Silva Costa pivoted to a modern Art Deco concept. Transforming the figure into a cross created a massive technical hurdle. The design resulted in a large, flat surface area across the chest and outstretched arms that catches the wind directly. At this altitude, that specific shape acts like a giant sail. During a hurricane, the air pressure exerted on the structure reaches hundreds of kilos per square meter. Silva Costa's aesthetic choice created a significant structural challenge that the standard building materials of the early 20th century were not equipped to handle. Engineers rejected steel because the salty ocean air would have caused the frame to rot within decades. Instead, they turned to reinforced concrete, a choice that was considered unconventional and risky for such a high-altitude project. To manage wind resistance, Albert Cacot designed a hollow 12-story building. This internal skeleton of diagonal pillars captures the massive wind load hitting the arms and directs that force downward, anchoring the entire structure into the mountain's granite base. On the fourth floor, workers molded a small concrete heart into the interior framework, a secret signature left by Silva Costa for future engineers to find. Beneath the religious exterior, a highly calculated structural framework absorbs and transfers the energy of the Atlantic winds. In 1926, there were no roads to the summit. Every kilogram of concrete, sand, and water had to be transported on this 19th century rock railway. While the core was built on site, the sculpture was designed in Paris. Paul Landowski crafted full-scale plaster models of the head and hands, which were then sectioned and shipped to Brazil to be used as molds. Space at the summit was extremely limited, requiring perfect coordination. Materials and molds had to arrive and be filled with concrete on the same day, often while workers were shrouded in thick, slippery clouds. Despite these hazardous conditions and the total lack of modern safety harnesses, the project was completed without a single fatality, a testament to the precision of the construction site. Reinforced concrete is naturally porous. Without protection, it would eventually crack under thermal stress and the constant humidity of the surrounding rainforest. Silva Costa used soapstone as a protective skin. The stone is soft enough to be easily cut when mined, but it hardens into an impermeable shield once it is exposed to the elements. Applying this shield required thousands of workers to glue 6 million small soapstone triangles onto linen sheets. These sheets were then applied to the statue like a mineral wallpaper. This handcrafted mosaic reflects light differently throughout the day, while successfully sealing the internal steel reinforcement against the forest's moisture. Sitting on an isolated 700-meter peak in a tropical zone makes the monument an epicenter for extremely violent electrical discharges. To prevent the concrete from shattering, the internal steel framework acts as a Faraday cage. Lightning rods in the head and hands channel the energy through the internal cage, bypassing the stone skin and dispersing it into the bedrock. The monument's skeleton acts as a sophisticated, grounded electrical grid, engineered to safely neutralize the force of tropical lightning. Even with these defenses, the power of tropical lightning can still vaporize the soapstone exterior. In 2014, a particularly violent strike destroyed the statue's right thumb. Repairing the damage requires specialized climbers to abseil from the head to reach the fingertips. They use soapstone from the original 1930s quarry to ensure the repair matches the original construction. The maintenance of the monument is a continuous effort, as crews work year-round to defend the structure against its environment. When the world saw the completed statue in October 1931, it represented a successful synthesis of structural engineering and Art Deco design. The project demonstrated that reinforced concrete could be used to create precise, large-scale art in even the most inaccessible locations. This monument stands as a hollow fortress with a concrete heart, an achievement that expanded the possibilities of vertical architecture.